In this lesson, we will work through an application of quadratic functions. The problem. Julia is planning to plant a flower garden along one side of her house. She has 32 feet of fencing. She will not need to fence along the house. What are the dimensions of the garden which will maximize the area? What is the maximum area? Let's start by drawing a picture. The vertical line here represents the house to the left of the vertical line. To the right of the vertical line, I'll sketch a rectangular area that will be Julia's flower garden. It helps to visualize what's going on by starting out with a diagram. Determine the objective function and equations resulting from constraints. So let's go ahead and resketch a picture of our flower garden and add some variables this time. Let's call that the width here x and the length y. Okay, the objective function. Our objective here is to find the maximum area. So for the objective function, I'll call my area A, and A here will be equal to x times y, the width times the length. The constraints, well, there's only one constraint here, and that is that the maximum amount of fencing we can use is 32 feet, and we do want to use that maximum amount of fencing. So 2x plus y, we're going to let be equal to 32 for our constraint. So 2x plus y would be the x plus y plus x. 2x plus y is the amount of fencing that we'll use for the garden. Use constraints to eliminate extra variables in the objective function. Our objective function is a equals x times y. We want our objective function in terms of only one variable. The constraint is 2x plus y equals 32. Using our constraint, we can solve for y. Y equals negative 2x plus 32, and then use our constraint to substitute for the y in the area function. So a is going to equal x times negative 2x plus 32. This simplifies to negative 2x squared plus 32x. Okay, so this is our objective function in terms of only one variable. Next, determine the absolute maximum of the objective function. Our objective function a of x equals negative 2x squared plus 32x. Here a of x means a is a function of x. If I sketch this objective function, this is a quadratic function graphed as a parabola, upside down parabola. So a parabola that opens downward, I should say. The axes here will be x and a, and my parabola has a vertex. The highest point on the graph of the parabola will be the vertex. The vertex will have an x and a value. The x value of the vertex will be the width of the flower garden that gives me the maximum area A. So let's see if we can figure out what that is. So to find the x coordinate of the vertex, we'll take negative b over 2a, which will be negative 32 over 2 times negative 2, and that is equal to 8 feet for our width of the flower garden. The area, we find a of 8, which would be negative 2 times 8 squared plus 32 times 8. The area, the maximum area then is going to be 128 square feet. Let's state the solution. What are the dimensions of the garden which will maximize the area? So we know the width, but to find the length y, the width is 8 feet. To find y, we go back to an equation we had somewhere along the way. Y is equal to 32 minus 2x. So we'll plug in 8 for x here. 32 minus 2 times 8 is equal to 16. So a y value of 16 feet is going to give us the length that provides that maximum area, that results in the maximum area. So our dimensions of the flower garden will be 8 feet by 16 feet. What is the maximum area? We figured that out earlier. The maximum area is 128 square feet. Try this next example on your own. Julia will use 90 feet of fencing to build a rectangular kennel for her 2 hunting dogs. She will use part of the 90 feet of fencing to place a divider down the middle of the pen to separate the dogs. What dimensions will provide the maximum area?